Welcome to Math 242. This is Calc 1. This is the first lecture of the series of the lecture for this semester. Our first topic is functions. I'm going to start with the definition. What is a function? A function is a set that for every input, you will get exactly one output. That means for every x that you pick as an input, that x belongs to a set. That set, we call it the domain. Then there is exactly one output y, and that output we call it range. That y belongs to the set range. Okay, so there are multiple ways to show a function. You can think about a function as like a relation between a couple of points. It could be letters of alphabet. It could be something like, okay, let's stick with this example. So here, let's say you have 3 points, 1, 2, and 3 from the set D as for the domain. And you want to relate these points to some points in the range. Again, they don't need to be 1, 2, and 3. They could be A, B, C, doesn't really matter. They could be A star C. But normally for our class, we deal with values. We do not deal with letters that much. Okay, so let's say we say F maps the point 1 to 0. Sorry, here, 1 to 0. That means if you give an input 1, you expect an output 0. As well, in this case, if you give 1, you see that you will get 5 as well. Here, if you pick 2 as an input, then the output is -1. If you pick 3, the output is 2. This kind of contradicts with the definition of the function because of only one point. And that point is specifically 1. Because if you pick 1 as an input, what you get is not one output. You will get more than one output. You get 2 outputs. If this ever happens, this cannot be considered as a function. So to make it a function, I'm going to erase one of these points. Let's say there is no 5. So now we don't have any issue. 1 goes to 0, 2 goes to -1, 3 goes to 2. These numbers could be the same as well. So let's say if you had 4, 4 can go to 0. That doesn't cause any problem. Because if you pick 4 as an input, what you get is exactly one output. You do not get more than one output. Even though that output is the same as the output for 1 as well. That doesn't cause the problem. The problem is if you pick one input, you expect at most one output. Not more than that. Okay, so here, this original example was not a function, but if we change it to this, it turns out to be a function. Here, let me go back a bit so we can compare. The notation, okay, so this is not a function. So the notation, sometimes they could use this set version. Sometimes they can use, sometimes they use this arrow. Sometimes they could use this set version. In the set version, you will see points, coordinate system. First coordinate, second coordinate. So here you will see 1 is the first coordinate, 0 is the second coordinate, 2 is the first coordinate, -1 is the second coordinate. And this is exactly the same as saying all the first coordinates are elements in the domain. That means those are your x values. And all the second coordinates are elements in the range. So if you compare this two shapes, one is the set version, the other one is the mapping version, they're exactly the same thing. What is the input? If you pick it as 1, then what do you get for output? You get 0. If you pick input 2, you'll get -1. If you pick input 3, you'll get output 2. If you pick input 1, you'll get output 5. So here is the dilemma that we dealt with here. We picked 1 and we got 2 different values. In the set version, you will see similarities. It means if you pick 1 as your input, you'll get 2 different outputs, both 0 and 5. So if this happens, this is not considered a function. It's just a set. We call it a relation, actually. So to avoid making such a problem, last time we erased the 5. We could erase the 0 and say this point, I don't want it in the domain. I don't want it in the function. I don't want it in the set, therefore I can make a function. So I've made a function, and this function has 3 points. Here are the 3 points. If you pick 2 as an input, what do you get as an output is -1. If you pick 3 as an input, you get 2 as an output, 1 and 5. So exactly for every input, you'll have at most 1 output. It is, if you pick the inputs in the domain, then you should have exactly 1. Sometimes you pick a number that doesn't belong to the domain, something like 7. If I pick 7, 7 is not connected to anywhere. So this point 7 does not belong to the domain at all to discuss it. So normally we only discuss the points that belongs to the domain of a function. Okay. Now, if you look at this, there is another version of writing a function. You can show it. If you remember, there was a point 1 and 0 here. Here, the points, you can show it on the xy plane. This is the xy plane. The point 1, 0 is 1, 0. The point 2, -1, here is 2, -1. 3, 2, and 1, 5. One important thing that you should notice is if I pick the same x value, 1, I have 2 y values, both 0 and there is 0, here is 5. But normally, if this happens, sorry about that, if this happens, then you'll see that you can say this is not a function, because if I pick x value of 1, which point do I discuss? Do I discuss this point to have y value of 0, or do I discuss this point to have y value of 5? So to avoid this, again, we erase one of the points and say, okay, now this is representation of a function. We could replace, you can erase 1, 0 and say we're going to keep 1, 5. Okay, it's all depending on which case do you want to deal with. Okay, so there is another representation. This is what we call it the graphing. This graphing representation has a nice way to figure out if you have a function or not, that I'm going to discuss in a bit. But if you look at the points that are exactly vertically above each other, if that ever happens, it means these 2 points have the same x value, but different y values. If that ever happens, then you do not have a function. And there is a test for this. We call it the vertical line test. Vertical line test. That means if you draw any vertical line, if it crosses 2 points, if 2 points belong to the same vertical line, then you do not have a function, because they both have the same x value, different y values. Okay, another way to show a function is through an expression of depending on x. Sometimes you've seen this stuff, something like x squared minus 2x plus 5, something like that. You write f of x equals that. This is an expression that depends on the input. You give input x, here you'll calculate some value. You'll get an output. That output is your y value. Okay, so normally we say y equals to f of x. Whatever comes out of the result of that expression, that would be the y value. For example, if you look at the sets and you look at the points, one way I can say is f of 1. That means if you give me the input 1, what do I get? I get 5 and 0. So I have f of 1 is 0, as well as f of 1 equals to 5. If this ever happens, you have 2 outputs for the same input, not a function. Okay, so we ignore one of these points and say, okay, to make it a function, I don't want to consider this point. I will erase this point in the vertical line test as well. So if you have f of 2 as -1, that means there is a point 2 and -1 here belong to the function. If you have f of 3 as 2, that means x is 3, y value is 2. This is the input and output. X is 3, y is 2. Here's the point 3 and 2. Okay, these are all representation. I'm sure that you've seen it. I don't want to go into too much detail, but I just want to remind you of what the function is. And what is domain and range? Domain and range is the sets. If you look at the 2 sets, the elements in the sets, they call it the points in the domain and the points in the range. So here for the domain we had we had 1, 2, and 3. And for the range, we had 0, -1, 2, and 5. But remember that if we do this, if we pick these points for the range, then you do not have a function, and we erased one of them. So let's assume the 5 was not there. Okay, so those x and y values, this is the set of the x values, this is the set of y values. Oh, now vertical line test. This is what I was talking about earlier. By the way, a function can have infinite points. Here you can have like 3.2, 1.9, 2.8, all those connected to somewhere else on the other side. So you can have infinite points. If this happens, that means you'll have like infinite number of points connected to each other. So you will draw it as a curve because all these infinite points will basically are connected. So when you plot a function, you draw a curve or something. Erase this maybe. It's just you saying that all those infinite points are going through here, something like that. This is your function. So every point belongs to this set. The x value is in the domain. The y value belongs to the range. Okay, so every point. So normally when you see graphing, that means that function has infinite number of points for the input as well as for the output. So here, the vertical line test, if you remember, I mentioned above, that means if you find 2 points vertically above each other, then you do not have a function on a curve. If that happens, then you do not have a function. That means if you draw any vertical line and crosses the curve more than once, then you say, okay, these 2 points have the same x value, but they have different y value. This one may be 2, this one is -3. Then what can I say is I can say this is not a function because I picked some x value here. I pick x value of 2. What did I get? I get y value of 2 as well as y value of -3. So therefore, this is not a function. Okay, so not a function. Vertical line test is very easy. Yeah. If you ever find one of these vertical lines that crosses more than once, it's enough to say it's not a function. So here in this case, if I draw this vertical line, it only crosses one time. If I draw another one, it only crosses one time. But if I draw it at this point, you'll see it crosses at these 2 points. Then now it is not a function. To avoid that, most of the time you will see that they turn one of these into open circle. That means that point is not belong to the domain. That means if this was like -3, and they give you these 2 y values as 2 and 1, and ask you what is f of -3, then you should say at -3 what is the y value? The y value that I see is this point. The y value is basically 2. That's what it means when you see open circle. If they were both closed circle, then that means at -3 I have 2 values, both 1 and 2. I do not know which one to pick, so therefore this should not be a function. So normally you will see open circles at one end of this graph. Okay, how about this one? This is simply a function because every vertical line crosses one time. Sometimes you draw a line that doesn't cross at all. That doesn't cause any problem. If crosses more than once, that's going to be the issue. Yeah. Okay, so here, let's discuss the graphing as well. These are all something that you've seen before, but I'm just going to go through it. So let's say you're given this function, f of x is x squared minus 1, is an expression depending on the variable x. Then we want to sketch and find the domain and range based on the graphing. Normally for the graphing, you have an independent variable. That variable is for us x, and you want to find out the y value. What is the y value? Y value is basically the f of x. So I'll pick something like -2, -1, 0, 1, and 2. These are independent values that I pick to find out what do I get correspond to for the y values. If I replace -2 into the function f, to evaluate f of -2, it would be every time I see x, I'll replace -2, so -2 squared, don't forget the parentheses, -1, this is 3, so y value is 3. At -2, I have y value of 3. If you calculate f of -1, you'll get 0, so this would be 0. If you calculate f of 1, sorry, f of 0, you'll get -1. F of 1 becomes 0, and f of 2 is simply 3. So you'll get 0, -1, 0, and 3. So I have a bunch of points. If I draw those points, this is a simple example, so you don't need to pick a million points. But if the function looks complicated, you can pick more points. Okay, so here, the point -2 and 3. This is -2. It's 3. Sorry about the scaling is not good, but I shouldn't have done that. Okay, so here is the point -2 and 3. The point -1 and 0 belongs to the x-axis. 0 and -1 somewhere here. 1, 0, and 2 and 3. You can assume that if I pick more points, if I pick something like 1.3, at 1.3 I will have some y value here. At 1.4 there will be another y value. So these are all points. If you pick more points, you will see that it will fill up these gaps between these points. What you would get is some curve. And this curve is basically a quadratic. It's a parabola, a quadratic shape that is very common. You see. Just be careful that these points all belong to that curve. Okay, here's one thing that is important. If I pick any point on this curve, for example, if I pick some point with a x value of 3, the corresponding y value, whatever this is, it should satisfy this equation. That means if you replace 3, you get 3 squared minus 1, which is 8. This must be exactly 8, nothing that. If you pick something like 5 and 2, this is 5 and 2. 5 and 2, since does not belong to the curve, that means it shouldn't satisfy this equation. It means if you pick 5 for x, 5 squared minus 1, it should not equal to 2. If it equals to 2, that means it belongs to the curve. Okay, so in this case, 5 and 2, 5 squared minus 1 is not equal to 2. Therefore, it's not belong to that curve. Okay. This is important to notice that f of 5 does not equal 2. Otherwise, it would have belonged to this curve. Okay. So we sketched the graph. How about the domain? What is the domain? This is a very important thing to notice. The domain is always what we focus on. The range is not that easy to figure out. But the domain is something that you should always figure out. The domain of this function, what can I pick for x? You can pick any number that you want. If you replace it for x, you'll get a different y value. That means I can pick any number, replace it in the function. It doesn't cause any issue. You'll get a corresponding y value. If I pick 1,000,000, say some zeros, f of 1,000,000 would be a number. 1,000,000 squared minus 1. There would be a number. So therefore, for this x value, there is a y value. And there is only one y value, not more than that. Therefore, that x value belongs to the domain. There is no problem with any input. So the domain is all real numbers. Right? There's interval -infinity to infinity. How about the range? What is the range? What do you get for the y value? In this case, I'm going to show you this idea that if you have a graph already, you can project. If you project this curve onto the x-axis, what area would you cover? If you project it, you would cover this section. So let's assume you squeeze this graph up and from above and below, and you will squeeze it all the way down into the x-axis. What area do you cover? Is this section. But this curve will keep going in each direction. That means this number line you will cover more and more. That's why we have the domain to be all real numbers. That means all the x values will get covered. How about the y? If you project it on the y-axis, which area would you cover? If you project the graph on the y-axis, what you cover is only this section and above, because the curve is continuously going. So by doing the projection, we can say, okay, the range only stays from here all the way above. So this is -1, I can say from -1 to positive infinity. And you see that at -1 I use bracket because -1 is already belong to the range. There is a y value of -1. The y values are always above -1. So the projection onto the x and y axis basically tells you the domain and range. Based on the graphing, this should be. Sometimes you do not want to graph it, and here's an example for the domain. So they ask you to find the domain of a function. I picked two examples. F of x is a rational function, g of x is a square root function. So here, let's first find the domain of the rational function, f. So we want to find out what is the domain of... Sorry about that. It's the allergy season for me. What is the domain of f? If you're dealing with fraction, this is one thing that you should know. This denominator can never be 0. That's the only restriction that you have for fractions. So if you're dealing with functions that have fraction involved, you look at the denominator and say, okay, this denominator can never be 0. If it is 0, then you have an undefined fraction. So we want to figure out where is x squared minus x minus 6 equal to 0. And exclude those points that makes the denominator 0. Where do we get x squared minus x minus 6 equal to 0? If you should know factoring x minus 3, x plus 2. These are from college algebra, so I'm not going to focus that much on it. You'll get two solutions, 3 and -2. So that means if you pick 3, what happens for the f? If I ask you what is f of 3, you'll get 2 times 3 minus 1 divided by 3 squared minus 3 minus 6. What you get is 5 divided by 0. You see that the denominator is 0. Denominator 0 means undefined fraction. So that means this is undefined. That means if you pick x value of 3, there is no corresponding y value. So therefore 3 cannot be acceptable in the domain. As well as if you try -2, you'll get 0 in the denominator again. So that would not be acceptable either. So what do we say for the domain? Domain of f. You can write it as all real numbers minus, this backslash means minus 3 and -2. That means I will take out these 2 points. Every other number is acceptable because it doesn't make the denominator 0. If it would have made the denominator 0, you would make this equation 0 already. So this is the domain. Sometimes they write it this way. Sometimes they write it all the x's such that x does not equal to 3 or x does not equal to -2. This is another way to write it. I think the textbook mentions this one. I'm okay if you use this notation. This one is acceptable. The very common one for your homeworks is to write it as an interval. You say, okay, here's the number line. -2, 3. These 2 points are not acceptable. So I'll consider them open circle. Everywhere else, totally fine. I can accept any number here, any number here, any number in this section. So how do you write this interval is from -infinity to -2. Union from -2 to 3. -2 to 3. Union from 3 to positive infinity. 3 to positive infinity. I only excluded these 2 points, -2 and 3. Sometimes instead of union, they use comma in the homework. Just be careful, figure out which one do they want. All 3 acceptable for me on the exam, but for the homework and quizzes, make sure that you use the correct notation. How about the g function? What is the domain of g? The domain of g, okay, domain of g. You look at the g function and say, okay, I can replace any number I want. Not really, because if you're dealing with square root, you notice that if you have a negative number underneath the square root, then you're dealing with complex number. We're not going to discuss complex numbers for functions. We only discuss real values for these functions. So what do you want is, we don't want to have negative number underneath the square root. So whatever is underneath the square root must be greater than or equal to 0. That is the only restriction. So what do I set up is inequality and say underneath the square root, whatever it is, 2x minus 8 must be greater than or equal to 0. And you solve this inequality. That tells you the domain of this function. If you add 8 and divide by 2, you'll get x greater than 4. This is one way to write it. The other way is, say, from 4 to positive infinity. So this is the domain of G. For the square roots, it's not too complicated as long as you can solve the inequality correctly. Okay. And by the way, this notation's x greater than or less than, you can always draw the number line and say this is 4 equal. This equal sign means acceptable point, and greater than 4, everything on the right side. So it would be all this section up to here. Okay, that's the same as 4 and infinity. Okay, let's calculate some values, because in case you've forgotten, what is given f of x is x squared minus x, find certain things. We can calculate f of numbers, but what is f of t? That means replace x with t. Nothing complicated about that. It would be every time you see x, you replace t squared minus t. This is just to show you that it doesn't need to always have variable x. Sometimes you use t, sometimes you use v, u, whatever. Sometimes the function is a function expression based on the type, so they use t normally for it. What is f of negative x? That means every time you see x, replace negative x. Negative x squared minus negative x. Just make sure that you use parentheses. You can simplify it. Negative x squared is x squared minus x plus x. So this would be the function. F of a plus h, that means every time you see x, replace a plus h. This is the input. So I'll get a plus h squared minus a plus h. You can calculate a plus h squared, write it twice and multiply it. We'll get a squared plus 2ah plus h squared. Again, I'm skipping some steps, but I'm hoping that you guys know how to do a plus h squared, which is a plus h times a plus h. You should distribute. This is something from earlier in college algebra, you should know. So what we get is this expression for f of a plus h. Why am I talking about f of a plus h? This is something that we're going to use very often. And it's this formula. It depends on f of a plus h, sometimes f of x plus h. So this is called the, sorry, I think this is f of a, not f of a. This is called the difference quotient. Difference quotient. We will come back and use this when we discuss the limits, but it's very important that you can calculate. If they ask you to calculate this fraction, f of a plus h, we already figured out what is f of a plus h. It was a squared plus 2ah plus h squared minus a minus h. This was f of a plus h. Minus f of a. What is f of a? Into the function f, we replace a. Into the function f, I replace a. Minus is f of a plus h. Minus f of a, which is a squared minus a. Again, this is f of a plus h. This is f of a. And I'll divide by h. Now distribute this negative sign and simplify. You would have a squared plus 2ah plus h squared minus a minus h minus a squared plus a divided by h. Here, similar terms you can cancel out. A and negative a will cancel out. Negative a squared and a squared will cancel out. So what is left? Simply 2ah plus h squared minus h divided by h. Numerator, what do you see in common? It's an h. I can factor that. You'll have 2a plus h minus 1 divided by h. These will cancel out. So what did I end up with is 2a plus h minus 1. This is very important because later on we're going to discuss derivative, and this basically gives us the definition for the derivatives. Okay. Make sure that you pick another example and go through that. I think in the homework you will see more of these. Okay, f of x is this format. This is called a piecewise function. I just wanted to make sure that you guys have seen it. So f of x equals to these two expressions. Sometimes it's 2, sometimes it's 3 and 4 and so on. You can have multiple expressions. But the domain is broken down in this format. They say if your input x is less than -3, use this expression. If the input is greater than or equal to -3, use this expression. If they ask you to find out what is f of 5, for example, you'll say, this is the x value, x is 5. Where does 5 stay? 5 is less than -3, not really. 5 is greater than -3? Yes. So 5 is greater than -3. I can use this second expression and say, okay, now I'm using the absolute value function. Absolute value of 5 is simply 5. How about if they ask you to find out f of -3? -3 belongs to the second expression again. -3 is greater than or equal to -3. The first one does not have equality. So I will say absolute value of -3 equals 3. How about f of -2? -2, again, don't make this mistake. -2 is not less than -3. -2 is still greater than -3. Absolute value of -2. If they ask you for f of -5, then now here, -5 is less than -3. Therefore, I use the first expression, 2 minus -5 equals 7. Okay, all these are just simple calculation, but you need to make sure that your input belongs to the corresponding interval that you're using for that expression. So if I pick 10 as an input, 10 belongs to the second domain, x greater than -3, therefore I use the second expression. Okay, symmetry of functions. This is, I think, maybe not every college algebra sections cover this, but I think at some point you might have seen it. Symmetry for functions, there is two types. We call it the odd and even function. The symmetries can happen around the y-axis or origin. If the symmetry happens around the y-axis, then we have an even function. So we say f is even if you have symmetry about the y-axis. F is odd if you have symmetry about the origin. So just based on the graphing, you can say this is symmetric about the y-axis. So this is an even function. This one is symmetric about the origin. That means, what does it mean symmetric about the y-axis? Means if you pick a point here exactly on the other side, correspond to the y-axis, flip this point, you get the other one. Here, if I pick a point here exactly across origin, there's another point on the graph. For every point I pick here, exactly across the origin, there is another point on the other side. If that happens, then we have an odd function. Okay, so what is the relation? The relation that you have is, if I pick this x value and look at the other x value, which is exactly apart. So one is x, the other one is -x. They both give me the same y value. They both have the same y value. So what does it mean? That means f of -x and f of x are equal. They both have the same y value. On the other side, if I pick this x value, I'll get some y value. And corresponding on the other side, you would have -x. What would you get for the y value? You will get -y. So what is the relation between the f? The f's are opposite of each other. So f of -x is not equal to f of x, but opposite of f of x. So negative f of x. If that happens, then we have an odd function. We use this definition for odd and even just to figure out if you're given the equation and you do not have the graph. So here's 3 examples. We want to figure out which one is odd, even, or sometimes you have neither. And it's possible that you have a graph that is not symmetric at all. Something like if I had this line, it's not symmetric about the origin or y-axis. Therefore, it's not odd or even. The first function, you always calculate f of -x. See what happens. And I'm going to calculate g of -x as well, and h of -x. And I will compare it. f of negative x squared plus 1. Simplify, you'll get x squared plus 1. G of negative x, you'll get negative x cube, which is negative x cube. H of negative x, it would be 2 times negative x plus 1, which is negative 2x plus 1. Okay, so now let's compare. What is the relation between f of negative x and f of x? This is f of negative x and that's f of x. They're equal to each other, so this is equal to f of x. If that happens, what can I say? I can say this is an even function. The f is even. How about the relation between g with g of x and g of negative x? G of x is x cubed, g of negative x is negative x cubed. You'll see that they're not exactly the same, they're just off by a negative sign. If that happens, then you have an odd function. What is the relation between h and hx and h negative x? H of x is 2x plus 1, h of negative x is negative 2x plus 1. Are they equal? Not really. Are they opposite? Here's the important part. If they were opposite, they should have been, this is not equal to f, this is not equal to negative f of x. Negative f of x would be negative 2x minus 1, because you have to multiply negative to the whole thing. But here you have negative 2x plus 1. This is not equal to that. So therefore, this is not equal to the negative f of x either. It's not equal to f of x either. This doesn't happen. So if it doesn't equal to either one, then you can say this is a neither case. This is, neither odd or even, nor odd or even, whatever. Okay, so just make sure that you calculate the f of negative x or g of negative x, whatever that is. Compare it to the function. See, is it the same function? Is it the opposite of it, or maybe neither case? Okay, one last topic for this section is the increasing and decreasing function. We do not discuss it based on the expression, we only discussed it based on the graphing at this point. And later on when we discuss derivative, you can simply figure out the result just by giving the expression. Okay, so let's say you have this function. Sorry about being wobbly, the plot, but I tried to draw multiple points here. First, what is the increasing and decreasing definition? Definition is if you go from left to right. So this says x1 is less than x2. That means if you go from left to right in the direction. So if you have x1 somewhere here, x2 somewhere here. If you move this direction, if the y values, this is the y value, y1 and y2. If the y value is increasing, that means if the left y value is smaller than the y value, then you have an increasing function. It's just moving. If you go from left to right, if the function is increasing in terms of y, then you have an increasing function. So the increasing part is just for the y values. So if the y value is going up, then you have an increasing function. On the other side, if you're going left to right, but the y value is coming down, then you have a decreasing function. I don't want to stick with this mathematical notation. I just want you to understand. Okay, so if you look at this graph, let me draw this, erase these arrows. Okay, so if we look at this graph and say, okay, where is the increasing part? The function is increasing in this section and then in this section as well. Okay, so how do you write it? This is the important part. How do they write the result if they ask you where is the increasing and decreasing interval? This is the important part. Increasing interval. That means for what x values this function is increasing. The x values do not belong, they do not reflect by this drawing. They reflect by whatever happens down here. So you project it onto the x-axis and say, okay, in this area, you see that the y values are increasing. So therefore, for these x values, that y values are increasing, as well as in this area, the y values are going up. So therefore, in this section, the function is increasing. So how do I write it? I write it as an interval. By the way, this function is continuously going on. This is just forever. So I'll say from negative infinity to a the function is increasing, as well as from B to C. And where is it decreasing? Decreasing in this section, as well as in that section. You see that the y values do not really matter if you're talking about the interval. So the decreasing interval is from A to B, and then from C to infinity. A to B and C to infinity. I wrote letters, but these could be numbers. This could be -1, 2, 3, and so on. If you understand the letters, the numbers would be easier. Okay, this increasing and decreasing part is nothing complicated. Just make sure that you're using the x values to show the interval, not the y values. If there is a y value 5 here, I don't really care about that, to show the increasing and decreasing. If they ask you for the maximum and minimum, then I would care about this point. But for the increasing and decreasing, we don't really care about the y value. Okay, let's stop here. This would be our first lecture. This is section 1.1.